Buddy. We are today working on Unit 1, and before we can kind of dig into ASP.NET Core, we have to learn a little bit about the C# programming language. If you manage to look at your textbook, you will have noticed that the author does talk about the importance of actually knowing this language, or at least this style of language. And this is a variant of the regular C programming language. We call it Microsoft's version of C++, basically, is really what it is. They call it C# to make it, a little more Microsoft. He did mention in the book, and I forget if it was chapter 1 or 2, where he talks a little bit about what languages work inside this environment. And this is kind of an interesting little thought. The one primary language that Microsoft uses for all the development now is C#. And the alternatives for working in ASP.NET Core would be VB.NET, so Visual Basic, which is the predecessor to C#, and then a language called F#, which a lot of people don't know about, but that's a proprietary Microsoft language that's kind of like a weird mix between the two with its own strange syntax. Now, as we're kind of like venturing into this space, yes, other languages work with this within this environment. When I first started doing .NET, it was all Visual Basic driven. And then somewhere around 10, 15 years ago, it started shifting over to the C#. And then by 2020, or maybe even a little earlier than that, Microsoft had basically kind of abandoned Visual Basic. Not that it's not still there and working, but in favor of using strictly C#. And so that's the language we're going to focus on here. Why is it important? Because when we write backend code for .NET Core, C# is the language of choice. C# technically is an open source, open platform language capable of running on any platform that has the right libraries in place. That wasn't always the case when we used to do .NET development in the past. And I'm not really sure what just happened to all my Zoom screens here, but there we go. When we used to do this in the past, and we did it on top of the straight .NET platform, not the .NET Core platform, it was very Microsoft centric, and that obviously has changed, and that's a good thing. If you know other C style languages, this will be an easy pickup, and that's why I'm not spending, half the course teaching you this programming language and the other half doing .NET. The class is about .NET, so that's where we're going to focus most of our attention. However, there are times where we have to write back-end code, and knowing at least how the language operates or where to find stuff about the language so you can make it operate the way you want is pretty important. So let's start with this first entry that I dropped in here, and I'm going to explain what I have here. And the first thing I'm going to say is I know that you'll see a whole bunch of videos here, and you'll see how long they are, right? I have no expectation that you guys are going to like take the time to go through all this stuff, because it's a combination of lecture over PowerPoints with demonstration and then exercise completion for a different course at a different school. But it is in the form of all these videos that you see here, a complete course in C#. So if you are really, wanting to learn this, feel free. It's all there for the taking. This is all available on YouTube through my private channel or whatever. And so you can go there and watch all these videos. Here they're organized collectively with descriptions and when they were recorded. And you can see that this was not that long ago that I recorded this stuff. Probably the more special part to pay attention to are the lecture videos where we talk about the technology and kind of build up as we go. We cover basically most of the fundamental language features, including, data types, the syntax, functions, loops, et cetera, that type of thing. Now, this is probably most comparable to the Java language compared to any of the others that you learn here, at least within the web program, right? Python has got a lot of significant differences from C#, but C# is a C style language, so is Java. And let's actually kind of scroll down here, and I just want to show you the rest of the stuff here. So there's all the slideshows that go with the lectures, right? So if you want to just kind of read up on C# a little bit, these can be helpful. I think they're better with the videos, though. Just saying it. The other thing that I have here are all the reference links that I had from that course. And you can see a majority of them come from W3 Schools, the same site that we use as a reference for HTML, CSS, and JavaScript, and a number of other languages. But they have a great section on C#. And then there's also a few Microsoft tutorials down here that you can link to as well if you just want to check it out. Now, what my goal is here for tonight is to kind of introduce you to the language and its syntax, and then do a couple of really basic demonstrations that basically will comprise the homework. So if you code along with me, the homework will basically be done. It's not going to be anything challenging. I'm not going to have you do like anything super bizarre, or, like where you're going to have to put your thinking cap on and work on it for hours. This is really just an intro to the language. And then at that point, what I expect of people at this level of programming, now that you've learned a few languages, that whenever you need to figure out how to blank, you will know how to figure out where to go and what questions to ask to get the code that you need. Now, if we do something more advanced in the book, of course, we'll explain it. But in terms of having to write something from scratch, in other words, come up with your own programming logic, it's kind of becomes on you as the programmer to kind of figure it out at this point. Once again, this is not a course in C#. If you are interested in that, I'm just putting it out there, we do offer a course called Introduction to Programming and Databases. That's part of our software program that does introduce you to C# on, basically the same level I have here in all these videos and slides. They cover both console and GUI programming and database work in that class. And then in the software program, they also add a follow-up course called Advanced Microcomputer Programming or something like that. So that's if you want to go deeper into the C# world. For web developers, though, generally, we don't worry so much about the back-end code as much as we worry about the frameworks and the APIs and the calls that we have to all those pieces and making the website go. And once again, when we need programming logic, we figure that out and drop it in on the back end. We don't think too much about it, real frankly. All right, so the first thing I'm going to do is I am going to jump us over to W3 Schools, and I'm just going to start talking about the language on a basic level, and then quickly rifle through what I think are the main features of the language, and then we'll do a little sample program, and then we'll move on to other material, right? I'm not even going to spend the whole session on this, if you're wondering. So let's just, I'm going to zoom in just a couple of clicks here. Part of the reason for that is to try to get rid of the ads. We'll see if that works. There we go. All right. So when you see this moniker, right, notice it's not a C++, it's a C#, and that's how you say it. C# was developed by Microsoft for its own internal purposes. Once again, a variant of the C language. It's built on top of the .NET framework, also works on top of .NET Core, which is what we're using. What can you use C# for? Well, anything that you can use any language for, from real fundamental stuff to, very complicated things, and even operating system development if you have to. It is the primary language that is used to develop the Windows operating system and most of its core software. Whenever we work with C#, and I don't know if they have really good graphics of this in the book or not, basically in Windows, whenever you compile code inside of Visual Studio, it goes through this thing called the Common Language Runtime, the CLR, that then allows it to run on top of the virtual machine, which runs .NET Framework apps, right? So kind of like the way that Java operates, there's kind of like this layer that isolates your .NET programs from the actual operating system and kind of keeps it from crashing, basically, if there's a problem with the software. But it's just a way, basically, and really truly, whenever you're using Visual Studio, to write in just about any language you want, but still have it pushed to the same language libraries and operating system libraries, and still have the software work. Now, this is Windows centric, but C Sharp is an open source language, and it is capable of running via the .NET Core libraries on Linux and Macintosh machines, right? If you ask me, and I think we had a slight conversation about this before we rolled, is it okay that I just use my Mac the whole time? And I'd say, yeah, absolutely, it's okay. But really, truly, this is still a Windows technology, so you might find some advantages to working within Windows. So and that's a personal choice. You can see here they start talking about what you can use it for. So web apps, desktop, mobile, games, et cetera, et cetera, et cetera. Anything that you can code with this language, right? Um, Predominantly, it was used to do GUI development of apps, but it also does console development. And any of the examples I show you here today will probably be in a console format, by the way. They have examples, right? And so let's just take a look here really quickly at their first example, and you'll see some really interesting kind of things about working with this language that kind of separate it from other languages. First thing that you notice is, unlike Python, right? So if that's your basis of comparison, it is a curly brace and semicolon based language. So in other words, every statement is terminated with a semicolon, right? Any block of code that's named somehow open and closes with a curly bracket. And like Java, where we call our programs a class, same thing here. And then notice even the main method is similar, right? Like if you think of like Java and it's like public static void main, right? All those little modifiers that we would use. Same things apply here. So I can actually add to it public class program or public static void main. I mean, the syntax is almost identical. There are a couple of variances. In Java, this would be a lowercase m, and that would be a capital S, by the way. Kind of interesting. But otherwise, everything is really basically structured the same. The one notable difference, and this is a choice, by the way, when you spin up a console program, at least, that you also have an encapsulating namespace. And this is probably the part that throws people the most when they're new to C Sharp. If you're used to other languages, is this namespace construct. But basically, what it allows you to do is to have a whole bunch of programs working together underneath one named umbrella. So in other words, namespace is really just a container for all your programs. So if I was working in Visual Studio and I had one project I was working on and I had 20 programs, all part of the same namespace, um, they become separate entities within that namespace, but you could take those components and maybe pick them up and move them to a different namespace that has the same thing, like why reinvent the wheel concept, right? So the namespace becomes a hierarchy, kind of like files and folders or something, but it's not really that. It is a naming convention more than anything. So you may see C# programs with or without the namespace. The default is to include the namespace, by the way. Now, what I'm going to do here is, and you can see that we have an app up on the screen already, and this is the classic Hello World. And it doesn't take a genius to figure out what this does, but what if we create this inside of Visual Studio? So this would be kind of like the first step of the homework here. And now what we're going to do here is we are going to create a program, but we're not going to create a web app like we did last time. What we are going to create is a console program intentionally. So launch your Visual Studio, get that up on the screen, and you should get this splash screen that comes up. And I'm going to go ahead and choose to create a new project. So I'm going to go ahead and click on that and get that up on the screen. All right. So I don't know if you guys remember last time we were playing a little bit with this secondary screen, and you'll notice that when you've worked with certain project types, often they will appear here in the left sidebar. So I have done the core web app and console apps, and a console app is what I'm targeting right now. That's just a a plain command line kind of app. Now, one of the tricks to using this product and using all the gazillion templates that come with it, by the way, is working with these filters. And what I'm going to do here is I'm going to disable all the filters. So, which language? Well, any of the ones that are supported, and you can see the ones that are already loaded up in here, right? Now you could say C sharp if you want, so you could filter down, and that will eliminate all the non C sharp style apps from the list. What platform? Well, we're going to be multi-platform, so we're not going to pick one, but you could pick Windows or Linux or whatever you want. And then project types, you'll notice all the different project types. And really what we're searching for ultimately is console. So if you're not seeing console appear right up at the top, then select console and it should narrow it down. Now I want you to notice there's a difference here. We want the top one. So we don't want the one that's on the .NET framework, right? Because that's the Windows only one. We want the one that's going to be multi-platform, which is the top one. So I'm going to go ahead and select that. I'm going to click next. And then you'll be asked to name this. So I'm going to say that this is up to you where you want to put this and how you want to store it. And right now I'm looking at the storage location that I have, and I was obviously probably grading homework or something, which is why I'm attached to a project testing folder on my desktop. That's abnormal for me. So what I'm going to do is I'm going to switch over to my Google Drive. I'm going to find my folder for this class, which is 152.178. And then I'm going to make a new folder for 2024 summer. And then I'm going to select that folder. That's where I'm going to store my stuff for this summer. Okay. The thing that I'm building right now is I'm going to call this Unit 1 console app, just something really basic. And that's just to kind of learn the fundamentals of the language. Right. There's this interesting thing that happens when you're working in this environment, and whenever you create any sort of a programming project, there's an auxiliary file that's created called a solution file. And that's what this little box is about. And that'll generate a file with a .sln extension to it, which is basically a file that contains, I like to think of it as pointers to all the project resources. So I can go to that one file, double click it, and it opens up the project and everything that goes with it. Right. Now, you can name that solution file differently than the name of the project, right? So like, and we can go down a whole rabbit hole on that even, but the most typical thing to do is if you're creating an app and you're calling it whatever, you just let the solution file be called the same thing. Usually that makes sense. If your project is complicated, you might not, right? So I'm just kind of putting that out there. The other checkbox you have here is it says place solution and project in the same directory. Now, once again, if the project is complicated, I would not check that box. I would leave that unchecked, because then I could have multiple projects all linked together under one solution. Kind of see where I'm going with that. Because this is going to be very simplistic, I'm checking the box and I'm saying put the solution file and the project in the same folder. It does make sense. And notice where it's going to put it. So for me, it's going to be on my Google Drive in my 2024 summer folder, and then in a new folder called Unit, and actually I want it to be Unit 1 console app. All right, so I caught my mistake. All right. Once you have it named, you have a location picked, go ahead and click next. Now I'm going to give you one little caveat. I discovered when I was working on certain types of applications with .NET that if I used a cloud-based drive, and I'm about to do that, this is my Google Drive, or if you use OneDrive or Dropbox, sometimes there can be problems keeping the files updated as you're coding. So in that case, you might want to consider maybe even using GitHub as your repository as opposed to storing here. That is something that you can add to any project at any point. All right, clicking next. All right. And then here we choose our framework. Now, this book that we're using is built around .NET 7. So there's no reason not to choose that version, which should be the latest, right? And that's the one I'm going with. And then notice that it also has this little checkbox here. And this is kind of an important one. It says, do not use top level statements. Now, what the heck is a top level statement? Here is a top level statement right now in the background of this box is the namespace. So I can create console apps and skip the namespace. Like if I'm just writing a simple console app, just trying to get stuff up on the screen, I can just bypass that little component. If I'm building a normal app, though, typically I don't want to do that. I want it to namespace everything. It's just makes it more future proof. It makes it more robust, or at least possible to be robust. But for right now, I'm checking that box. Do not use top level statements. So here we go, clicking create. This is going to take a moment to build out the project, and then load up the product. And of course, it did the opposite of what I thought it would do. So it still put the namespace in there, whatever. There it is. It doesn't matter at this point if we have it there or not, but I feel silly because I thought I was making it change. Now, here's the problem that you might run into with a cloud-based drive. So if OneDrive, Dropbox, Google Drive, and it says the solution has been modified outside the environment. Press reload to upload, and so I'm going to do that. But what can happen is those cloud drives like to sync their files. And then if it's noticing that it's syncing, it can change timestamps. It can cause problems, basically. So might be one reason why you want to use GitHub or just a straight up local folder. Just putting it out there. All right, we have this loaded up onto the screen right now, and all it takes to run this very simple program is to execute by pressing the play button up here at the top. So I'm going to go ahead and do that just to make sure that it works. You can see it does some messages at the bottom. It will open up a command prompt window. It will execute the program, and you can see up there it executed. And then it gives me a message saying it's all done. Press any key to close this window. And so we proved that it works. So what I would like you guys to do at this point, just to prove to me that you're able to get in here and tweak a couple of things, is we're going to replicate the default output screen, which is the console right line. And I want you to notice how slick it is with the autocomplete in Visual Studio. And I want you just to add some other message like, my name is, or something like that would be kind of helpful. Now notice I have not put a semicolon at the end, and notice how it's highlighting red. This is a standard feature of Visual Studio. It's to kind of point out that you're making a mistake, and it says semicolon expected, show potential fixes. So you could either click on that or Alt Enter, right? And it shows what the fix is, and then you can choose the fix and apply it, right? And I don't see that any of these are actually correct, so I'm just going to manually add a semicolon. All right. The level of, I'm going to say, autocomplete and IntelliSense inside of this product is actually so powerful, it's kind of crazy at times. You can also integrate Copilot, which is Microsoft's AI generating tool, by the way, which for most students, I say don't do that, but if you feel like you're ready for it, go for it. You can add that as a component. And notice that this is picked up on the fact that I did a couple console write lines, and I haven't typed in console write line, but you see it grayed out there. Like it's like, oh, you're probably going to do another one, aren't you? Right. So you know what? If you see it's suggesting code and you just want to grab it, you just hit tab, right? And then I'm going to throw in, one more statement, and then I'm going to exit out of the parens there, put in a semicolon, and I'm going to run this again. I just want to make sure that it works, all right? And you can see, very, very basic, but we are getting stuff up on the screen, right? What we're going to do now is we're just going to keep kind of trying different examples, playing with them a little bit, adding to this program, and that's going to be our experiment. And then this file will get turned in, or this program. All right. Flipping back over to W3 Schools, I think we got a good example of the hello world. And when we start kind of digging through their content here, and I'm just going to go to this area here, and I'm going to try to hit as many of these as I can as quickly as I can. By the way, so my hope is not to bore you to death. Okay. Um, all right. So, what is C sharp? So we talked about that. Um, it does stem originally from the C language. It has a lot of similarities with C++ and Java. And so, if you know either one of those languages, heck, even JavaScript is similar. Um, a lot of the syntax and techniques are sometimes pretty intuitive. It's very little nuances that will throw you. Examples of why to use C sharp, what it's used for, why to use it. It says it's one of the most popular languages in the world. That is true, just by virtue of the fact that it's used to create Windows. Um, Easy to learn and simple to use. Well, perhaps, huge community support, absolutely. Object oriented in all the same ways that like Java is, very much so. Um, and you notice that last bullet, it's so close to C, C++, and Java that it's people that know those languages often have very, very little transition they have to make to get to using it, right? Very little. Um, they do talk about, what tools to use, right? And so they go through kind of the whole same spiel that I go through. Ultimately, I think that regular Visual Studio is the best tool, and I'm noticing that they're suggesting the same product and the community version. The current version, as I record this video, is 2022, and then they give you the download link and all that. They talk about what you need to install. And if you guys, this looks just like what we did in class last week, right? And they tell you which libraries to select, right? And then ultimately you can kind of build from there, right? And they go through kind of like the whole same thing I just went through with the splash screen, and you see how they're the console app with .NET Core. That's the multi-platform one, and that's perfect for all the stuff that you see both on their website here and in this one unit that we're doing to cover C sharp. Notice how they have examples of where to store things. I do find that this is kind of interesting because this is actually the default location. And notice how it's outside of any OneDrive or Google Drive or Dropbox or any shared cloud location. And it puts it in a weird name inside your user folder, not a place you would normally look, by the way. And then it is also possible to separate out your solution files from your actual code files. Not something I recommend, but they show you an example of the screens. And then once again, all the same stuff that we just did, right? Um, Moving on, let's go to the syntax screen here. Um, Now, when you do create a console app like the one that we just created, the default name for it is program, right? Like with Java, and I just kind of want to point this out that these are what we call conventions and not rules, right? Whenever you name a program, it is a class, but notice that it starts with a capital letter. Why? That's the convention. It's not a rule, by the way. You can name it lowercase, but what does have to happen is that your program file name, which is program.cs, .cs is for C sharp, must match exactly with the class name of the file. That's just kind of one of the rules, right? If it's uppercase, it's uppercase, lowercase, lowercase. It is case sensitive. What the convention is, you start with a capital letter, right? You can't start with a number, can't start with punctuation, if I remember correctly. Kind of all the same naming conventions that you have in Java. So very familiar with that as a technique. All right, so now they kind of go through and show a couple of the little conventions here. The using statements in C sharp would be the equivalent to the import statements that we use in Java. And what this means is we are using, in this case, the system library. And the system library is the one that allows us to write line to the console. So that's where the write line function or method can be found, is in the system library. System is usually automatically included because you usually do want to read and write to the screen or other components. As you start adding more complicated features to your programs and you start to use like certain web components, for example, you will have a growing list of using statements the same way you would in Java if you had import statements. So like in Java, when you're doing like JavaFX, for example, you're importing that library in order to be able to use it. Or if you're writing database statements, then you're importing the database libraries, right? Same thing here, we just use the keyword using. I did mention how we have curly brackets and semicolons, right? So all of that kind of, fits that same paradigm. They have some helpful little tips here, and I think that, kind of maybe the most interesting little tidbit here out of all these little notes, just like when we use import statements in Java, the reason we use using system is so that we can directly say console write line. And if we omitted this, then we'd have to also include the library designator in front of it, which is a namespace for a program that has a method, right? So this is kind of like the mystery sauce, basically. So somewhere there's a system library that has the console program, or class or whatever that structure actually is, has a method written inside of it that puts the content on the screen. Either you use the fully qualified name or you use the using statement and then just use that part, right? Pretty straight ahead. Every C# statement ends with a semicolon, right? Blocks of code are inside curly brackets. It is case sensitive, and that's true of really most things. Now, I'm seeing an interesting note here, and so I'm going to correct myself. Obviously, it says, unlike Java, the name of the C# file does not have to match the class name. Okay, so there I am, very wrong. But they often do. Okay, so it's a convention, right? Didn't I say that before? For better organization, and most programmers tend to follow that. Whenever you do save a program, then, so if you're creating one from scratch, the convention is uppercase first letter and a .cs, to get that out there. Moving on to output. Now we've already done this, so I'm going to kind of go over it pretty quickly. We use the console write line statement, and I think we've already figured out that each write line creates one line of text on the screen, right? Very, very similar to like a print statement in Python, or I'm trying to think of like Java is system out print line, right? This is the console write line is the example of system out print line in Java, basically. So I want the correlation. Can I output math in a write line? Well, you know what? You can. So let's do that. Let's output some math. The other thing I can do here, right, is I could just console write line a blank line, and then I can maybe do a little header output some math. I'm going to add my semicolon, console write line again, and this time I'm just going to hard code some numbers. And then we'll go ahead and run this just to prove that it can do it. And so there you go. So you see the blank line that I added, some more text, and then yes, it can do the same thing that Java can do, and that is take math equations placed within the parens and process them as math, and then output the result as a string, right? Because anything that comes to and from the screen is a string, and that's true of just about any language, actually every language, right? So yes, you can do math. You can also do a write statement, which would put the content on the same line. So if I was to just maybe borrow these two lines rather than retype them, right? Maybe I'll do a blank one first. Right, that's a good thing to do. And then I'll just paste those 2 lines in. So now if I run this, you will see that those two lines printed concurrently, or one right after the other, because they did a write that ended here, and then that would print on the same line, right? All right, so that's a pretty basic example, but very similar once again to Java. So now it doesn't know what to auto suggest for me, so I'm gonna do another write line. I'm just doing a blank line in here on purpose. So interestingly, when we do get to use this stuff to do web pages, what we might end up putting in the write line or write statements is actually um, a variable that might contain HTML, or in some cases, HTML directly. But we wouldn't be writing to the console, we would be writing to the browser. That's kind of an interesting thought, right? So you can use your C# code to push HTML or CSS or JavaScript, by the way, to the browser window and push it out through the web. If you want to comment your code, you can do this a couple of different ways. So you can add a comment either as a standalone line or at the end of the line, right? So let's just try that really quick. So I can throw in a line here, double slash, and say this is a comment, or I can put one at the end of a line and say this is also a comment. So that's one method for commenting in C#. You can do multi-line commenting, so you can use your CSS style commenting marks if you wish. I'm not going to demonstrate that one, but if you know how you do that in CSS, same principle, pretty handy technique. And is it good to do one versus the other? Well, it depends on what you're doing. If you have a whole bunch of text, use the multi-line. All right. Now we're going to get into a little bit meatier material here, and we're going to talk a little bit about some of the basic data types. Now, like Java and like the C and C++ languages, C# has more than a few types of especially numeric data types that it considers basic data types. The data types that are probably used most often are the ones that we see on the screen right now, and I'm going to play a little bit with all of these, right? And you'll see, like, for example, int is for integer, helpful since it's just like Java, right? Double is for floating point numbers, not to be confused with decimals, which are also floating point numbers but have different capacities. And then we also have ints of various types, by the way. So there's ints where you can add like kind of capacity definitions to them. Not going to get into that here. We can also do single characters. We can do strings. That is a data type. Notice how, like in Java, when we do strings, it's a capital S because it's actually a class. Same is true here, but we use a lowercase s here, so don't fall into that trap. And then if we're doing a Boolean, it's bool, right? So how do we declare them? We declare the type, we give it a name, and then optionally assign it a value. So like they have an example here of a string. So I'm just going to go ahead and just create one really quick. So I'm going to just say string, and I'm going to say first name equals one of my standards, whatever, right, with the semicolon. And then I can go to console, write line, and I didn't type that in, folks, right? It just auto suggested it. It looked at what I typed and it's like, hey, you might want to put your first name on the screen. Okay, here you go. I just pressed tab and it grabbed it, right? And don't be reluctant to take advantage of that IntelliSense and autocomplete. Go with it, right? This is a general thing. And you will learn that its capability is so great, it kind of blows my mind, like how intuitive it really is. Let's run this just to show you that it works, right? And then it's outputting whatever. Yeah, that's my first name, but that's what I told it to do. Let's follow some of their other examples here. So they have an integer, a number, and then they're going to write line that number. And I want you to see here that they're doing it two different ways. So we're going to play with it a couple of different ways. So let's do an int, and I'll call it, I don't know, num1. And then see, it's suggesting, all right, we'll go with the number 2. Sorry, 0 wasn't what I had in mind. And then we'll do another integer. We'll call it num2. Okay, 3. I'll go with it, right? Now we are getting a green underline. What the heck is that about? Well, let's hover and find out. That's how you do that here. It says the variable num1 is assigned, but its value is never used. And right now, when you're building a program and you're assigning things to a variable, you are occupying memory space, which makes your program more inefficient. And if you're never using it, you might want to consider disabling it or commenting it out or something, or deleting it. All right. So now it's suggesting, right? So it's suggesting I'll put the first number, I'll put the second number. You guys see how much I'm typing this, right? Not like basically not at all. I'm going to do a write line again, and this time I'm going to actually have it add num1. And actually, let's multiply. So let's use num1 and num2, right? And let's go ahead and run this, right? Let's see what it does. It's pretty intuitive. So there's num1, num2, and 6, which is the result, right? So that's working with integers. I can also, if I want, declare an integer like this and not give it a value, and then subsequently give it a value like so. Right. And that's one of the examples that they were showing. And then, of course, we could, output that if we wish. And we'll just let it do it. And then, of course, if you want to run it, go for it and run it just to prove that it works. Pretty basic, really, right? And I hope I'm not going too fast for you guys. If I am, please make me put the brakes on and repeat. But I think this stuff's pretty pedestrian, especially when you know other languages, right? And if you haven't realized it yet, once you have those languages under your belt, right, it is so easy to pick up new ones, right? And yeah, I mean, it's really kind of what it's all about. All right, let's keep going here with the examples. So they can also, like other variables in other languages, you can assign a value to something and then change it later, right? And I think that's pretty self-explanatory. But there are also all these other data types, and I'm just going to grab all of this and just drop it right in, right? So we have an int called mynum, my double num, my letter, my bool, and my text. And I'm going to do something really super goofy here is I'm going to console write line, but I'm going to combine a bunch of this stuff together. So I'm going to say my double num, and this is kind of interesting because it's got a D after it, and that is an indicator that it's a double in essence. And then I'm going to concatenate, so you can do that here too, right? So I'm going to have my letter plus my bool plus my text plus, I guess that's all of it. All right, so let's see if that will work. Now, it is flagging it as a problem, and let's see why, right? The operator plus cannot be applied to operands of type double and type Boolean. So I can't output those. So that's where it's a little different. So let's get rid of my double, right? Now, the reason for that is it does require a conversion to push it to the screen, but you'll see that these two will work just fine. And the conversion basically will happen in the form of running a function that does the conversion. So I'm not too worried about that right now. We'll get to that as we kind of roll here. So those are variables. If you want to declare a constant, then you use the keyword constant, right? So like if I want to lock in a value at const, I think we use the same thing in Java, right? You can see I'm like questioning myself on that. And the one thing I'm noticing is they're not using the convention here of all uppercase. I'm going to say that that's still a convention in C#, even if they're not showing it here. So like normally if we were doing a constant, we name it like all uppercase, not camel case, but underscores. And that way, when you look at it in your code, you know that it is a constant immediately. So we do have constants here as well. If I want to intermix string output and concatenate, that's what we were doing before. I kind of did that a little bit, right? Or if I have two pieces of string and I can concatenate them together, store them in a different string, and then output the final string, that works too. Right? And, you know, as with any of this, if you just want to try it, it's okay to just do it. Right? I'm going to add a blank line there and just paste that stuff in. And let's just run it just to show that it works. Oh, there are build errors. What are the build errors? Okay, I see a red underline there. Oh, the local variable or function is already defined. Well, okay, so if it's already defined, I don't have to call it a string again. Now I'm just changing it, right? And now I should be able to run it. But you notice how, as with Java, if there's an error in the code, it's just not going to work. Okay, so there's an example of that. Let's move on here. Here's an example of setting a couple of numeric integers, outputting their thing. I think we've already done that. If we're going to output a whole bunch of variables, we can output them all like this. I want you to notice that you can, like in Java, multiple declare variables on one line. If they're all the same data type, you can just simply assign their values and comma separate them, and you can just keep going. Right? So that's the thing we do in Java very commonly. Or you can declare them all and then assign them all later. And this is a really clever assignment technique. And I do this one in Java all the time, where if I want three things to all be the same, well, x equals y and y equals z and z equals 50, and they all equal 50. It works from right to left. So whatever's on the right gets assigned, you know, so 50 goes into z, z goes into y, y goes into x, and they're all the same, right? So that's an example there. And then we also talk about, you know, what is good naming conventions. And you know what? The general rules of programming apply here, folks. The modern convention these days is to be verbose, to typically use camel casing to try to explain what is being contained as best as you can. There are some situations, you know, where, okay, and they're using this as an example. This makes sense more than this does, right? Because this explains what you're looking at. Not easy to understand, but you know what? If you're the programmer, like maybe you just put a comment in and explain it. But the modern convention these days is really to kind of explain in the naming directly. All right, so we're going to go back over to data types now, and we're going to take a look at some of these data types. And these are the ones that are I'm going to say most common. There are still others aside from the ones that you see on the list here, but you have an int, and notice that holds numbers basically up to 2 billion, right? That's billion. And then if you need to store more than that, and I don't know what that gets up to the longs, but longs have a higher capacity than integers, right? And that's something you have to kind of know. Floating point numbers stores fractional numbers, and it says up to 6 to 7 decimal digits. Doubles are more accurate. That goes up to 15 decimal digits. Then, of course, we have Booleans, which are either true or false. Characters, which is single characters of a string, and then a string, which is a sequence of characters and really is actually more complicated data structures. A couple of things that are kind of interesting about working with numbers is when you are working with longs, they add an L to the end. Now, I don't know if you guys caught this in Java, but Java does the same thing. We have that same exact convention in Java with longer integer values. Floating point values, we can, ideally, they say, with an F for floats and a D for doubles, to basically, tell the compiler to store only a certain amount of it. So in other words, if I'm, a floating point value takes a certain amount of memory, if I put the F in here, it helps to kind of control that memory is really the best way I can explain it. And you saw what the consequences are of that, right? So it does output that, but intermingling it with other things doesn't work so elegantly, but a direct output works, right? Same thing is true with the doubles. The direct output works, but intermingling it and concatenating it doesn't. Why do we have like different types of numbers? Well, it's all about precision, basically. Um, and if we wanted to use what we call scientific notation uh, or exponential expressions, that is possible. And notice the use of the E to indicate powers of 10, right? So that's available here as well. Like other languages, C# also allows for casting. So in other words, um, when you are working with numbers and you're doing, typically you're doing math with them, right? That means if I take, let's say, like a floating point number and combine it with an integer and multiply them, what is the output? Or if I, let's say, divide a floating point number into an integer, what happens? And there's basically the automatic casting, which is basically converts a smaller type to a larger type size automatically. And then you can actually manually control this process as well. And sometimes, and I'm going to say you have to know what the math is before you would do that, right? And sometimes you'll find that you're doing stuff and it will cast in a way you don't want it. And then you have to hot rod the numbers a little bit. So in other words, you might have to add a 0.0 to an integer in order to make it do its math correctly. They go through and explain how that works here. I'm not going to spend a lot of time on it. If you did want to convert your data types to other formats for output, right? So if I wanted to take my double number and convert it to an integer 32, right? And so we didn't even talk about that data type, but that's another large integer type. There's methods that are built in that convert things to other formats, either for doing math or for output. ToString is often used for doing output, and then two other number formats for controlling things. If I wanted to output a Boolean, for example, I have to call convert to string, and then it will put it on the screen. It doesn't just say true. A little bit different than Java. How do we handle user input? Well, in a console program, we have a special command where basically we prompt the user with a standard output statement, and then we do what we call a console read line that captures whatever was typed, and then the pressing of enter on the keyboard, then it stores it somewhere. But the key here is the read line command and then having somewhere to put it, right? So it can't just go nowhere, it has to go somewhere. Common thing is to put it into a variable, although it's possible also to, in some cases, have something output directly. So I could actually do a console read line right in Spot here, and it would work too, right? If you want to try these commands, you can very easily copy these in. And this might be one of the last things that we actually add to the program here. So let's do a blank console write line, and then I'll just paste in all that stuff. So enter a username, we'll absorb it, and then we will output it. So let's try that, right? See how it's prompting. I'm just going to type, whatever, like I normally do, and then it will regurgitate that back to the screen. Very, very simple, but that's how we do user input. There's a green underline here, right? And, this is kind of an interesting little feature here. And I want you guys to notice the syntax at the top of this box. And notice the question mark that comes after the string data type declaration. And then, Jonathan, I know that you've had the Swift class recently, and this kind of correlates a little bit to what we were doing there. And now it makes you understand kind of where they got it from. But basically the question mark here is indicating like, all right, well, you're setting up this variable that's going to capture something from the keyboard. What if they don't enter anything, right? And so that question mark um, will prevent it from being null, basically, by including that. And they're recommending that as a fix, right? So really, and I did not want to go there. Okay, I did not want the documentation on that. So normally, if something could fail or maybe potentially be null, you put a question mark in there. So that, and I forget what they call it. I think they call it optionals here, if I remember right. Um, so same kind of stipulations here with other inputs. The last thing I'm going to do really quickly here is I'm going to rifle through operators, a couple of other high-end features, and then we'll cap it on this lecture, and then we'll take a break. All right, so this demonstrates more examples of input, and then we start to talk about our operators. So like when we do math, it's all the standard operators that we're already used to in programming, maybe a couple of exceptions. So, all right, the standard math operations, add, subtract, multiply, divide, the same, plus, minus, asterisk, and forward slash for those. Modulus is the percent sign, and that works just like it does in other languages. And then we have a plus plus and a minus minus as our increment and decrement, right? We have our assignment statements also. So we have a regular equal sign, which allows you to assign a value to a variable. We can also use these compound operators. So I want you to be really careful with those whenever you use them, by the way. But you can do a plus equals, a minus equals, and if you scroll down on the chart, you can do multiply equal, divide equal, modulus equal, and oh my God, a whole bunch of other ones. And these bottom ones here, I think you generally have to be really, really careful with. Multiply and divide might make sense to you, but some of these other ones you really have to think through the mathematical operations before you apply it. And that's all I'm going to say on those right now. We also have comparison operators, and these are also typical as to other languages. So double equal checks for equivalency. There's exclamation equal or not equal, less than, greater than, equal to, less than, or equal to, same thing. And then we also have logical operators, but notice how they're expressed in C#. So an and is two ampersands put together. An or is two pipes put together. And then you have the logical not, which is just an exclamation point. And what's interesting about that one, I think, is that you can take it and put it in front of other expressions, right, that resolve to a Boolean value to negate their meaning. So that's pretty useful. They talk about the fact that they have math libraries and a bunch of standard math functions. And you see square root, min, and max are demonstrated here. We also have ones that are related to strings. So we can do the length of a string, that's a built-in function, convert things to upper and lower case, which is a very common thing to do as well. Concatenation generally works like other languages. The plus sign is usually the concatenation symbol. And the other thing is you can call the concat function and concatenate things together. And then if you want to try to intermingle numbers and strings, it can get a little bit hairy, right? Because these are numbers, these are strings. This will result in math. This will result in joining two strings together, right? So a different approach. There is also this thing that we call interpolation. So here's another tie-in to the Swift programming language. We can also do this in Python, right, with an F string thing, if you guys have ever done that technique. But if not, if you wanted to use string interpolation, basically throw in a $sign to any either right line statement or string, and then you can drop in variables inside of curly brackets directly inside the double quotes, right? I like this approach. This tends to be the more modern approach that most programmers are starting to convert to, and that is called string interpolation, and C# does support it. All right, I'm going to skip down to Booleans really quick. So Booleans typically are true or false, all lowercase in this language. It's not true with every language, by the way. And Booleans are usually used to test true or false conditions or trigger true and false conditions. If else statements are supported, kind of very similar to Java. So if and then a condition inside of parentheses, right? and then you can do an output. Um, so I'm just going to kind of leave it. If you want to throw an if else is possible as well, or if you want to do if else. So one condition, second condition. Notice, unlike Python, it's not elif. It's fully spelled out, just like Java, else if in a complete condition. There is also what we call a ternary operator, and we do demonstrate this, I think, in Java very quickly, and you do see it in JavaScript. This is also supported in Python, by the way, where we check a condition. This is basically the if. So if that's true, then we do this part. Otherwise, we do that part. And this is called a ternary operator. So whenever you see a question mark and a colon in the middle of an expression, that's what it is. It's a weird if statement. There's also the switch statement, which is available, right? Very common also in Java and other languages. Um, Python does not formally have this structure. This is kind of interesting, but I think they added something similar with 3.10 or 3.11. And I think they call it match instead of switch. So that should be interesting to watch. But a switch is maybe a better way to do like an if, else if, else if, else if kind of thing. Switch is often a little bit more efficient. The other thing that we'll look at it very quickly are while loops. So these work like they do in most languages. We test the condition. If it's true, the loop runs. We also have for loops. And for loops work just like they do in Java. So basically, we have some sort of a precondition check, the condition which operates the loop while true, and then the increment or decrement or some statement that's executed every time, right? That's a typical for loop. There's also the for each loop, which is more Python-like in essence, which allows you to take like a structured collection of information, be it a list or a dictionary or an array or whatever, and automatically traverse it, right? So that's what a for each does. And then we do have array structures for collections, right? So that's what an array looks like with square brackets. Notice you can hard code them or whatever. And then just a couple last things, and we'll call it here. We also have the ability to create methods, right? So in other words, we can take a block of code and name it, and then we can call that block of code to make it execute, right? So this is a call. This is the definition. Methods can include parameters, so you can send them values for processing. And they can also return values as well, and then when you call them or set them up, you have to indicate the return type right there. And then you have to have somewhere for it to go when it comes back. Very, very common. And then not to get into any of these things here, but basically C# is an object-oriented programming language. That means you can create classes, you can instantiate objects. Classes and objects can have data fields and built-in methods and constructor functions, and allow for overloading of parameters and I'm trying to think like inheritance and polymorphism and all those features that we're used to from Java. All that stuff is capable here in C#. But that's going to truncate this little lecture video, folks. That's your primer to C#. Now, the one thing that I'll tell you is the stuff that I did here in my example. You can feel free to experiment much more so with the code, but if you do something at least this basic, save it, show me screenshots of all of your code so I can see the code, submit the CS file. You can zip the folder or just give me the CS file, that's fine. And then also, once you have the program successfully running, if you could show me the console output as well and screen capture that. So that would be the entirety of the C# piece. All right, this video ends here, folks.